Okay, we are back for section 4.9 and 4.10. We're doing them together today because it is with the last PowerPoint that I have, I think. I might have a different PowerPoint later, but anyway, this one's the one for today. Today we're going to talk about distance problems. Distance problems can also be called rate problems, but it has to do with distance, time, and speed. They use a chart. I say as well because there were other problems in the slideshow that used a chart, but they use a chart, and once you know the chart and fill it in, you can set up the equation and solve. It's a piece of cake as long as you use the chart. If you don't use the chart, then you won't be able to do it. So make sure you always draw the chart when you talk about distance problems. It's just like when we talked about mixture problems, we had the buckets that we had to always draw. Well, this time we always have a chart. You need to know that rate times time is equal to distance, so make sure you write that down. And this is what our chart looks like every single time. Have a plane or a bike or some sort of mode of transportation there and some sort of mode of transportation there. It doesn't matter what they are, your problem will dictate that. And your total at the bottom. Across the top you have your rate or speed, because that's the same thing, and then you have time, and then at the end you have distance. That's what your chart looks like every single time. So every single time you're going to have to draw the same chart. It looks like you're drawing tic-tac-toe problems, but you're not. It's doing math, I promise. Let's look at the first problem. I hope you've already got these problems already cut out for you. This one is a problem about friends. I didn't write these problems, I promise you. They did come out of a book. Not your book, but a book. Your mom will have a kick out of it. You probably don't know who friends are, but that's okay. Monica and Chandler pass each other along a straight road traveling in opposite directions. Monica is traveling at 40 miles per hour and Chandler is at 50 miles per hour. In how many hours will the cars be 225 miles apart? It's a lot of words. A whole lot of words. Aren't you glad you don't have to write all those down? Okay, so we can tell we're talking about distance, right? Because they talk about distance. So the first thing we're going to do on our piece of paper is go ahead and draw the chart. So you have two lines here, and then you have your lines here so that you can go ahead and set up. Total's always at the bottom. Across the top you have your rate, your time, and your distance. Over here on the side, we have to decide what two things we're talking about. So here we're talking about Monica and we're talking about Chandler. So I'm going to write Monica in one and Chandler in the other. Now let's talk about the information they told us about Monica. They said Monica is driving at 40 miles per hour. So beside Monica, her rate is going to be 40. They said Chandler is at 50 miles per hour, so beside Chandler, his rate or speed is going to be 50. They want to know in how many hours will the cars be 225 miles apart. So whatever our hours are for Monica is going to have to be the same amount of hours for Chandler, because they're going the same amount of time. They started at the same amount of time when they passed each other, and they have to end at the same amount of time because they're going the same amount of time. Whenever they get to be 225 miles apart, they will both be 225 miles apart at the same time. So our time is going to be what we're looking for. In how many hours will the cars be 225 miles apart? So we want them to be 225 miles apart, right? That's why that goes down here at the bottom. That's our total. When will they be this far apart at the end? So I said that rate times time is equal to our distance. So now 40 times x has to equal our distance over here. Multiply across. 40 times x is 40x. 50 times x is 50x. And then we have to add down. if they are going, this part you need to write down, if they are going in the same direction, you subtract down. If they are going in opposite directions, you add down. This one said they were traveling in opposite directions. That's why we're going to add going down. So our equation has to be 40x plus 50x equals 225. Always get your equation from the last column. All this other stuff was getting us to this last column. So the last column is where our equation is. 40x plus 50x equals 225. So now that I have this, I can draw my line. 40x plus 50x, they're like terms. So that's going to give me 90x is equal to 225. Divide both sides by 90. And x is equal to 2.5 hours or 2 hours and 30 minutes. Either way. If they're going in the same direction, you subtract. Opposite directions, you add. Your turn to try one. If two planes leave Dallas Airport at the same time, one flying west and the other flying east, how long will it take them to be that many miles apart? Go ahead and draw your chart and try to fill it in. I'll give you some time. How about some music? Do 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 do. Do 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 boom boom. Okay. Got your chart. Rate, time, and distance. Have two planes. One of them was going west and one was going east. Now you didn't have to call yours west and east if you didn't want to. I always do that because that's what's in my problem. They use west and east in the problem. I use west and east over here. The one that was going west was going 530 miles per hour. The one that was flying east was flying at 620 miles per hour. How long will it take them to be 1725 miles apart? Their time has to be the same because they started at the same time. That means they have to end at the same time. And 1725 is how far apart we want them to be. And just like before, you multiply across, so 530 times x gives you 530x. 620 times x gives you 620x. Just like before, they were going in opposite directions. They didn't say that, but they did say one was going west and one was going east, and they're opposite each other. So that means my equation must be 530x plus 620x is equal to 1725. Now that we have the equation, go ahead and solve it. I'm not humming this time. Not doing doo-doos either. Really not gonna. I promise. I will bug you though until you get it done. 'Cause I'm a bugger that way. I bug all the time. Ask your mom, she'll tell you. So you draw the line. 530x plus 620x gives you 1150x. Divide both sides by 1150. And x is equal to 1.5 hours. Ta-da! Good job. Now, a slightly harder one. At 6 a.m., a train leaves Washington, D.C. traveling at 50 miles per hour. At 9 a.m., Another train leaves the same station traveling in the same direction at 75 miles per hour. How long will it take the second train to overtake the first one? How far will they be from the station at this time? That's a lot of work. Okay, let's do this one together. So we got our chart, rate, time, and distance. We got two different trains, right? We're both leaving Washington, D.C., both traveling at the same time, but we have an earlier train, which is 6 a.m., and a 9 a.m. train. Now, the rate of the 6 a.m. train is 50, and the rate of the 9 a.m. train is 75. Time for the 6 a.m. train is x plus 3. Why is it x plus 3? Well, the 9 a.m. train is going to be my x. So the 6 a.m. train has 3 more hours because it left 3 hours earlier than the 9 a.m. train. So that's why it's x plus 3. Once again, we have to multiply across. Make sure when you multiply across here that you multiply the 50 times the whole x plus 3, so put some parentheses in there. And you have the 75. Now I put a 0 down here. How come I put a 0 down here? Well, the total tells you how far apart they are at the end of the problem. They want to know when these trains are going to be in the same spot at the end of the problem. So they're not any far apart. That means they're 0 distance far apart. So their total distance at the end of the problem after all this time between the two trains is 0. Now, were we going in the same direction or opposite directions? They said the same direction, which means we're going to have to subtract. So that gives me 50 times x plus 3 minus this time 75x is equal to 0. Draw my line. On the left-hand side, I can distribute 50 times the x plus 3 and get 50x plus 150 minus 75x. That gives me 150 minus 25x, because 50x and negative 75x is negative 25. Subtract the 150 from both sides. That gives me negative 25x is equal to negative 150. Divide both sides by by negative 25, and you get x is 6 hours. So in 6 hours, they should have caught up. But what does that really mean? You can't just say 6 hours. If they were both traveling at 6 hours, that would mean something. But this one isn't both of them traveling at 6 hours. The 9 a.m. train is traveling 6 hours. The 6 a.m. train is traveling for 9 hours because it's 6 plus 3. They want to know how long it will take the second train to overtake the first one. This is the second one. How long does it take the second one? 6 hours. Then, how far will they be from the station at this time? So in order to figure that one out, we have to say 75 times 6. To get that this train is going to be 450 miles away from the station, and since the other train is the exact same spot, that's going to be 450 miles away from the station. If you wanted to, you could have plugged a 6 in up here and gotten 6 plus 3 is 9. 9 times 50 is 450 miles. So 450 miles is one of your answers, and 6 is one of your answers. Last one, not quite as hard as the last one we just did, even though it is the last problem we're doing. Two truckers are delivering materials from the same site. One leaves the site at 8, the other leaves the site at 8:15. If the first trucker travels at 60 miles per hour and the second at 65 miles per hour, at what time will the second trucker catch up to the first? Okay, so we have our chart. Rate, time, and distance. We got two different truckers, right? They called them first and second. I bet I called them first and second. Oh, I didn't. I said I had an 8 trucker and an 8:15 trucker. Which one do you think I said let be x? I'm curious now. I don't remember. So the 8 o'clock trucker travels at 60 miles per hour. The 8:15 trucker travels at 65. The time for the 8 o'clock trucker, I was right, is x plus 15, which means my 8:15 trucker is the x. That makes it all positive. We want to know when they're going to catch up to each other, so when they're going to be 0 miles apart, and multiply across. Same direction or opposite directions? They leave from the same site, they're going to the same place because they want to know when they're going to catch up to each other, so it must be a subtraction problem. So 60 times x plus 15 minus 65x is equal to 0. Now all we have to do is solve it. Draw the line, do our distributive property, combine our x's, subtract the 900, divide by the -5. X is equal to 180 minutes, or 3 hours. That wasn't what they asked you for, though. They specifically said, at what time will the second trucker catch up to the first? So if I were to put a 3 hours added on to the 8:15, we would get 11:15 is what time he would catch up to him. It's a long way to go for materials. You made it. Still alive. Only a few things we still need to talk about. You need to know when you're going to do these different kinds of problems. It's great that you can do mixture problems, and it's great that you can do rate problems, and it's great that you can do consecutive integer problems and regular number problems. All that is fine and wonderful. Percent interest problems, percent increase and decrease problems, all that is great. I'm so glad that you can do it, but if you don't know which one to do when, that's going to be a problem. You have to be able to tell which one you're going to be doing when. So, you know you're going to have a mixture problem when they use the word mix. You know it's going to be a distance problem when they talk about distance. You know it's going to be consecutive integer problems when they use the word consecutive integer. You know you're going to have to use u minus old over old equals percent over 100 when they say percent increase or percent decrease. You know you're going to have to use is over of equals percent over 100 when they ask about simple percentage problems. So now hopefully you'll have enough information that you'll be able to solve these problems that you're going to have on your test. Now I know you want to know what exactly is going to be on the test. Can't help you out much there. I haven't finished making it out yet. But what I can tell you is that on the test I will tell you, like I'll send it to your mom, what problems are best for you to do as a review out of the book, because I'm going to try to not make your test too difficult, because it's really easy to do, because I'm used to doing really hard problems. So I'm going to make a concerted effort not to make your test too difficult. So I'm going to have your mom tell you problems out of the book that you can do, or either I'll make out a worksheet for you, but I don't see the worksheet thing actually happening. I imagine it's going to be problems out of your book. But I will attach that to the information that I send her, so she should have some information on that. If she doesn't, which it could happen, if she doesn't, have her call me and we'll work something out spur of the moment, because by then I would have made out the test. Okay, so I will talk to you later. Oh wait, I always want to forget it, don't I? The classwork and homework for this section. Sections, technically. So, I think I'm going to get them just from this section alone. trying to read by computer light. On page 175, classwork, problem 1 and problem 5, and on page 175, homework, problem 3 and problem 7. I can tell you that on your test you're going to have at least one distance problem, at least one mixture problem, at least one consecutive integer problem, maybe two, at least one percent increase, percent decrease problem, and at least one, probably three, one of each kind of the is over of equals percent over 100, because that's just good thinking. I will talk to you later. Go study, finish your homework, all that good stuff. Toodles!